I'm Chance. I work at Red Hat and previously CoreOS. I came in with the acquisition, and I've been with CoreOS Red Hat for a little over 3 years. And Rob asked me if I would give a brief overview of what operator metering is, and if possible, also a demo. So I have all of that. I thought I'd start by just kind of giving the base idea of what metering is for, what its purpose is, and like what we aim to solve with it, and where you can find out more information. So we are part of the Operator Framework org in GitHub. So if you're familiar with SDK already, or OLM, the Operator Lifecycle Manager, we are one of the projects as part of this org under operator metering. So the project name is Operator Metering, but I want to preface that with the fact that this isn't necessarily only geared towards operator use cases, though that is probably the best way for to get better integration. If you do have an operator, then you can leverage metering in a more Kubernetes native way. So the base idea of metering is that we work closely together with your monitoring stack and potentially other data sources to collect data, store it for long term, and then provide the ability to report on it over time and slice and dice it the way you need. So let's see. Just to give a quick example of kind of what everything actually looks like, we have a guide on how to actually start from scratch, what it looks like to create custom resources for metering involving Prometheus queries, which it talks about here is how to write a Prometheus query, how to feed them into metering, is this portion here, and then continue to iterate until you get data in our database, after which you can query it using SQL right here. The SQL eventually ends up in another custom resource, which users can use to more dynamically iterate or to integrate directly with their operator. And that's what this looks like here. And then at the very end, let me scroll down, you can create a report which is actually going to run the SQL query with the various inputs that you specify and produce the results and make them available for querying, at which point you have an API, which you'll be able to query, and then get the results as a CSV. So what I'll do is I'll actually go through this in more detail, but that's just the rough rundown, is that it starts with a Prometheus query. You start ingesting the data through the reporting operator. Reporting operator then has the ability to query it using some SQL that either you write or we write, and then you get that query to run by creating a report or a scheduled report, which actually says, what do you want to report on? So in the background, I already have an installation of metering running. By default, it runs a set of pods for storing our data, for querying it, and then also for the part that runs collection and the actual queries themselves. In particular, the primary component here is the reporting operator. It's the one that does the data collection for Prometheus, and it's also what queries the database, which is Presto, for all the real work on the underlying data. We use HDFS for storage, but that is something you can change. You can actually also use S3 natively as basically a file system, is the way you can think of it. Or you can also use a local disk that is mountable on all the pods. So like NFS, BlusterFS, ZepFS, anything that's mountable by many pods could also be used as a storage engine for this instead of HDFS. As I mentioned before, we have a number of custom resources. Let me actually list this.
Can you make your font a tiny bit bigger, Chance? It's really tiny. Thank you.
Big resolution makes it a little hard to tell where it's right. Let me see if that gets the full list. Custom resource definitions. All right, so we have a number of custom resource definitions. So the top one here is the metering resource. It's kind of the resource that tells you to install everything. Our metering operator installs the pods listed above, Presto, Hive, reporting operator. It does all that through the metering resource, which is basically the config resource for installation. We have some Presto tables, which people don't usually interact with, but they're kind of for storing some of our state. And then the rest are all things that I would expect the end user to deal with. So there's a report data source, which is basically incoming data or data that already exists, and I'll show you that. There are report generation queries, which are the SQL queries that we saw before. There's the report Prometheus query, which is a Prometheus QL expression for collecting data out of Prometheus. And then there's reports and scheduled reports, which are the parts that actually act upon that data. The storage locations are a way for configuring whether or not you want your data to be stored in HDFS, S3, or a local file system, for example. So starting from the bottom up, I'll start with data collection portion. We have these report Prometheus queries, which are really simple. They are an actual Prometheus expression, PromQL queries. So let me make this a little bit easier to read. So I'm just pulling out the, really? That's all. 1 second here. Why is that? Oh, there we go. So we have an actual Prometheus QL expression right here. This is not the easiest to read, so I will make this font slightly smaller. See if I can get a line break in here. But this is a large Prometheus query expression that gets the container's memory usage and then does it by grouping it by pod level, so you get pod usage information instead of just container level. And then we do a bunch of joining basically at the end to correlate it with other Kubernetes data so that we have like the pod name, the node name, and the namespace. And so this query is just run by the configuration of a data source. Which actually is what maps eventually down to a real table that we can query. So the report data source has a Prometheus query name, which is the name of the report Prometheus query we looked at before, pod usage memory bytes, and that configures the operator to actually go and collect this periodically. This section normally can have some extra options for like how often to pull and like chunk sizing for like how much data to grab at once. But by default, it would just use some global defaults. And then we have a status, just like every CR, which stores other information about this resource. In this case, the table name field is set, indicating there's a database table created for this and that we're collecting the data. So now that we have a data source, we can actually query it from our database using a report generation query. So there can be many report generation queries that act on the data sources. That's kind of the idea, is that the data source is the underlying raw data, and then you can have 1, 0, or more queries that actually utilize the underlying data. That way, you don't actually have to collect the data more than once for processing it in different ways, which is obviously useful. So let me actually just open this in the edit view. So a report generation query, just like everything else, has a name. All this other stuff is auto-generated because it likes to fill in the metadata. We have a set of columns, which is basically what we expect this query to output in terms of like a database schema. If you're familiar with like a SQL table, this is roughly what that maps to, is the columns in that table, and then some extra information for how to display it. Reports can take in custom inputs, so you can like override their default behaviors and program them dynamically a little bit. Right now, most of our reports only allow overriding the start and end dates. And then there's the actual SQL query, which is just ANSI SQL that has some Go templates in it that get pre-processed before the query is run to allow us to do things a little more dynamically. So this SQL query is doing an aggregation on the namespace pod and node to get us a pod level usage query that indicates how much memory a pod has been using over time. And so we have a bunch of different ones, and I want to show you the one I'm going to run, which is the namespace memory usage query. And it's very similar. The main difference is it's got less columns, and let me show you the query. Spec query. The SQL query is the same, except instead of being grouped by the pod and the node and the namespace, it's just grouping by the namespace, which in the end will give us a sum total of memory usage in the namespace over time. So to use these, we have a concept of reports, schedule reports, and I've actually already created a schedule report for us. So the schedule report I want to show is this one. So we have an hourly report, two reports actually, one for memory usage and one for CPU usage. And what these do is they run the SQL query specified by the generation query field, and they run according to a particular schedule. We can do hourly, daily, monthly, whatever you want, really. We also support cron for the more flexible use cases as well. And so it will report from data starting at the reporting start time until the reporting end. We don't have a reporting end, so it's going to report forever, which is what I want for this purpose. And it will retroactively go back and fill in the data that's missing from the start, assuming we have the data collected from Prometheus already. And so, as I showed before, this has been running for about 10 hours since last night, so that we actually have some more than just a few rows of data. Before I show you that, though, we can see the status to indicate like where it's at in the report. If we're backlogged or anything, you can check where the last period it ran for is. And then, because I'm on OpenShift, but this works with really good like Kubernetes as well, I'm using routes. You can use load balancer services or node ports as well. I have a route that is configured to expose my endpoint at a particular domain name here. So I actually already have a command set up to query it. Yes, you can query it, but it's not really anything I'm too worried about. This is the iCluster. I set it up with auth using the OpenShift auth proxy, and I'm querying the route that I just showed before. And then this is the endpoint, the API v1 schedule reports get, and then a bit hard to see, but I'm querying for a particular report, which is the namespace CPU usage hourly, and I'm getting it in tabulated format. So when I query that, we basically get the results as tab delimited format for each column. Period start is the start time for the given scheduled interval. So it's an hourly report. So each period start to period end is 1 hour. The namespace is the namespace that we're calculating on. Data start and data end are the min and max of the values in that time range. And then the pod CPU usage core seconds is the CPU at every instance in time multiplied by the resolution of that data, all added together to get us an actual CPU core usage seconds. And then we do this for every hour. So we have 13 to 14, 14 to 15, and everything up down to basically the last hour, 15 to 16 UTC. We have that as well with memory. And you can see the same value, except it's in bytes, and it's a different set of values for these pods usage information. So this is actually all coming from node exporter at the end of the day, and then Prometheus collects node exporter data, and we do some extra processing with the SQL and the Prometheus query to get it into this format. But that means basically that if we ever needed to change how it works, all we have to really do is modify one of these resources, like the namespace memory usage request. I can just edit it and modify it to my needs. So that's the rough idea of like how you interact and use meter. But there are other things you can do. We're currently working on another concept, which is, let's see. Yeah. So this is a regular report, but the concept is that you can have custom inputs where you could imagine having a query that maybe is specific to a particular namespace, and you could add field inputs to it that customize the behavior so that it filters everything that's not the namespace that you want. Maybe your CI test namespace, and you only want to report on that namespace. So this is something that we just added and is currently being worked on, so I don't have a great demo of it because none of our queries utilize these custom inputs very heavily yet. But that's something that we just released. And then we're also working on, with this feature, a concept of rollup, which allows you to calculate really granular reports that have like maybe say like the hourly interval that I was showing. But then this could be rolled up into a daily report, which basically aggregates the hourly results, and then you could continue to aggregate at higher levels to have accurate snapshots either at one interval or at a higher interval, or sorry, resolution, without having to actually compute the whole series of data across the lower granularity. Yeah, so that's the rough idea. I don't really have a whole lot more. Given that all of this is just custom resources, the real power here is that you can program it using Kubernetes just the same way you could program anything else in Kubernetes. If you have an operator that wants to interact with this system, it can do so using typical Kubernetes technologies like operators or kubectl. So you don't really have to worry so much about like how does my component integrate. It's just the same way you would interact with any Kubernetes system. So long term, the SDK will likely have bindings to create various report queries, Prometheus queries, and will integrate directly with metering to be able to expose your metrics, make them collected by metering, and then potentially even report on them automatically without your operator having to do any really extra steps, potentially, except for define what the query should be. So that's where I'd like to see it go, but I'm open to any ideas as well. Anything you want to add to this, Rob? Or something I should cover?
No, I think you covered it. I do have a random few slides on some diagrams if that's useful for folks, but might as well just go ahead and share those really quick.
If there's any questions, just pop them in chat or unmute yourselves and ask them. Well, he's doing that. You got that shared? Okay, go. There you go.
So here's kind of how it all comes together. If a few examples of how you can use this in a real environment. So chances showing us all the reports and all the stuff under the hood, but at the end of the day, say if you want to do show back for a number of different teams, each team has 3 different projects and, they have a certain budget. You can run the reports that Chance was just talking about and get the usage. And on Amazon, we can actually correlate to a dollar amount, which is really cool using the Amazon billing API. And so you can get those into Excel and just sort them and group them by the different namespaces and total things up just manually. Or because these are all just using CSVs, you can actually import these into your business intelligence tool of choice, whatever you want to do, and make dashboards out of these and have a more automated flow. You can also start doing a number of kind of like augmented math, if you want to call it that. So if I've got like 2 bare metal clusters, for example, and I know how much that I'm leasing the hardware for a certain amount, maybe I've got a block of bandwidth that whether I use it or not still costs me money. And so if you wanted to combine all of that infrastructure cost together, of your shared like enterprise NAS device, for example, you can take some of the usage from these reports and combine it with that fixed cost and multiply that stuff together, and then show that back to your teams, whether in another Excel document or in that BI tool hook it up to any of the other cost reporting that you might be doing, email reports, that type of thing. And my favorite use case for this of all is you can shame teams that are underutilizing what they've reserved. So if you're, asking for more than 2x what you're using on the cluster itself, you can start shaming those teams, calculate the ratio of what they're using and what they're not, list them out, say exactly which apps need to be, yanked down to size, or even just go ahead and do that for them. You could have automation that's running that's automatically adjusting people's resource limits and that type of thing. So it's pretty exciting. This is, all using cluster metrics that we have today, and that is one whole use case for this. But you can also, export custom metrics from your operators, and so that is kind of the other use case of this. So the cluster monitoring and gaining insights from that is great. But if you've got a database operator and it's emitting metrics for the different things that it's tracking internally, the number of rebalance operations or things like that that are critical to how it works, or the number of tables that people have or the size of those tables, you can start exporting those and using this same framework to do that, which is pretty exciting. So that's kind of a reverse order. That's the high level. Chance gave you the low level. So let us know if you have any questions, and we're excited to be testing this out with folks on their Kubernetes clusters.